Okay, everybody, we'll get moving since we have you here. We don't want to take up your time. So welcome to Swagelok, Western New York's Webinar Wednesday. I am Chris Gilman, the Marketing Manager and your host this morning. Just wanted a couple notes here that we have everyone on mute, but there is a chat functionality. So please feel free to use that to ask any questions as we go through the presentation. Also, once Derrick does share his screen, on the right hand of your screen, you'll notice if you haven't used Zoom before, there's see the video boxes with the participants, and there's a functionality, a little dash up above in that you can minimize that screen so you can see the full presentation. So actually for today, we have something a little different from you. Instead of more of the traditional type of presentation, Derrick, our regional field engineer, is going to lead us through an interactive demonstration of the Swagelok Toolbox. That virtual toolbox resides on our website, Swagelok's website, and it provides valuable tools helping you make decisions regarding valve and regulator selection, best materials for corrosive environments, millions of CAD files that are out there as well. So Derrick will show you all of that. Just to give you some background on him, he's been with us, Swagelok, Western New York, for over 15 years, and he is our expert in the field, providing customers with fluid system evaluations, advisories, troubleshooting, designing system improvements, and training as well. So suffice to say, he is well versed in the use of these tools. So now I will hand it over to you, Derrick.
Yep, I appreciate that, Chris. So thank you all for attending and taking time out of your day. This is a little bit different. It's not a canned presentation. There is no PowerPoint. So I'm going to be using the Swagelok website in live time. So we did just have a power flicker, so hopefully everything stays running and we don't have to go to some auxiliary internet connection. But the intention with this is to really show you what our website is capable of. There's a lot of tools in here that you may not be aware of, and there's some that you probably are aware of, but just need some additional assistance in how to use them. If at any point I start talking too fast or it's choppy or something else, again, use the chat feature, try and slow me down. I have a tendency on these to fly through here, but there will be points throughout this that I'll stop and see if you guys have any questions, or girls have questions on it. But again, this is going to be an overview of the tools that are available to everybody free of charge on the swagelok.com website. So as it is, I hope everybody can see. Currently I'm in Chrome, not Internet Explorer. I don't know that there's a big difference between the two, but currently I'm using Chrome, and I'm on swagelok.com. This is our main page. I would also encourage you, if you haven't yet, to create an account so that you can log in and it kind of tracks your history. If you have a common part that you're always looking for, it'll show up in your cart more frequently. It'll be in your kind of recently searched for activities. So if you're commonly using the same things, if you're placing orders online, I encourage you to create an account. That also allows you to link to our internal webpage. So this is Swagelok, Western New York, after you choose a sales and service center. And this allows us to give some other internal notes. Swagelok has their kind of global website landing pages. It's more personal to some of the work that we do. So I encourage you, if you haven't yet, to create an account to get access to our local page as well. All of the tools are going to be on the main page, and if you try and do it from our local page, it actually redirects you back to swagelok.com. Everything we're going to look at today, and we're not going to do it in completion. I'm not going to go through all 8 of these, but we are going to go through a couple. Are going to be in this toolbox tab right here. So there's products, services. There's a lot of great information. What we're going to focus on today is going to be in the toolbox. So when this loads up, this is going to be a pretty comprehensive list of all of the existing tools that Swagelok offers that are at our disposal, at your disposal, at no cost. This is a free service for you. The ones we're going to focus on today are going to be the CAD files and sales drawings, the CV calculator, material selection guide, and the regulator flow curve generator. Those are going to be the main four. Those are probably going to be the most common from a technical standpoint that you're going to get into. The product catalog is here. If there's time, we'll run through that as well. But really, these are going to be the main four that we're going to address today. And I'm going to start with the CAD files and sales drawings because that's honestly the one that I use most frequently, and I imagine other engineers and technicians use this one all the time as well. So when you click on that link, it's going to open a new window, and this is going to give you the option to actually, let me clear this out here. I thought I did that. Okay, when it opens this page, this is going to give you access to all of the currently available Swagelok fittings, valves, regulators, and other configurations that are available for download. We try to make this simple. Everything is visual, so if you're looking for face seal fittings or pipe fitting, but you don't know what it's called, say, hey, I need one that looks like this. You can hit each of these knockdowns to get into better configurations of what you're looking for, whether it's a T, whether it's an elbow. So we try to make this simple, doing a lot of visual things, a lot of knockdowns. From here, you can choose each of your different materials, your size, and we also have some positive material identification. I want to state right up front, all of the models in here are considered dummy solids. So your valves, your regulators, there is no internal geometry. You can't simulate flow through a valve. You can't simulate flow through a needle valve handle or a regulator if you have software that's capable of doing that. Our models don't allow that. Dimensionally, they're accurate for all of your key dimensions, your overall lengths, your body thicknesses, etc. But they are dummy solids. You're not going to be able to do any engineering calculations through these. So I want to make sure everybody is clear with that. But what this allows you to do is, if you're not sure what your bill of material is, if you're not sure what the configuration actually looks like, you can go through, hit your size, visually look for the different components that you're trying to find, and it'll bring up a 3D preview so that you can manipulate, move it around, drag it, zoom in, zoom out. You can hide everything if you really want to spend time looking at what the internal geometry, again, on this dummy solid is. You'll notice on a Swagelok fitting, there are no ferrules shown. They're there in real life, but just for the sake of space and simplification, they're not actively in each of these models. And it gives you a lot of options in how you want to download it. So when you do find a fitting, this one is a 1-inch Swagelok cap, so this gets installed on 1-inch outer diameter tubing. Hopefully that's sized appropriately. The first thing you can do is click on a sales drawing. When you do that, it's going to ask for your information one time. You're not going to have to do this every single time. When you do that, it's going to download, and at that point you have a 2-dimensional sales drawing that's going to show all of your key dimensions, your overall length. This dimension here is going to be the tube length as it gets bottomed out into a fitting, and any other appropriate dimensions that it will help from a submittal standpoint, it will help from a space saving standpoint, etc. So your 2D drawings are immediately available. Your sales drawings are available. I'll find a different spot to put this bar here. I'll put it over here. So I can close these out. If you're going to download into 3D, there are a ton of different options, a ton of different formats, and it's really going to depend on what your drawing medium is. Since we internally use SolidWorks, most of the files that I save are going to be a step file. I save them as 214 because it's 11 better than 203. I've had success using these step files, so it gives you the opportunity to download one piece at a time, or there's another feature in here that I'm going to show you how to do this, and that's add to cart. So if you have a list of components, and typically that's what you have if you're creating a drawing. You're not going to do a drawing of a single part. Usually you have a list of things that you're going to need to create a drawing out of. So for example, if you knew what the part number was, right off the top of your head, you can hit this search box. It's going to bring up a lot of different options. That's going to allow us then to find which one it is. I want the standard 1-inch male connector, which is an SS-1610-1-16. At that point, I can verify that it is what I thought it was. Whoops, scroll down. I want it in this format again. I'm going to add this one to the cart. So now I have 2 different fitting configurations that are in this multi-CAD download. What this also allows you to do all at once, if you don't, and you don't have to do it this way, you can download each of them individually and save this to your hard drive, save it to whatever folder you want to have. What this allows you to do is kind of create a bill of material all at once, download it all at once, and then at that point you have all of your files downloaded at one time, which is a nice thing to be able to do. So if I were to have a bill of material that was typed separately, and these don't all have to be capitalized, if you don't want to, it's going to recognize what it is that we're looking to do. Could have hoses, could have regulators, could have pretty much anything in our standard product catalog. If we were to take all of these components, copy them, that's what I just did here. I could paste this into our multi-CAD download and then look for them all. It's going to find any of the ones that are available. So it's got the hose that I look for, it's got the regulator, it's got this elbow, it's got this male connector. I can add those to my downloading cart over here. If there's a part that I'm looking for that's not available, in this case, it flagged my check valve. The reason it did that is because of the cracking pressure, so I can look for a different cracking pressure. This one exists. And I can do that. I can download a 1 PSI cracking pressure instead of a 5 because they're going to be dimensionally the same. So you just have to pay attention when you are going to do that. That when you add something as a dummy solid, as something to represent another one, that you just have to change internally in your notes that it's going to be a 5 PSI cracking pressure instead of a 1 that you downloaded here. So what I can do now that I have all this in here is, oops, I've got to select how I want them. Let's say I want all of these as 3D files. I can select these all as my step 214. I can put my email address in here, if I spell it correctly. I didn't. And I can hit request a CAD file. It's going to send all of this detail in here. And now I'll get an email that has all 7 of these CAD files that then I can input into a single drawing whenever I'm ready to do it. Instead of doing it one by one, you can kind of batch them all together into a single email download, and then you'll have them ready to go. Are there any questions on this? Has anybody used the multi-CAD download before, or is most of what you end up doing, is it piece by piece with single downloads? Was anyone aware that this feature existed? No? Okay. Okay. Well, if there's any questions on how this works, it's pretty straightforward. You can browse by picture, you can browse by description over here. The one that's a little bit difficult is when you get into ball valves, because we list them in a couple of different places. It's not just under the ball valves tab. There's ball shutoff. There's an AFS ball valve that's explicit to that series. So we don't list them all in one location, which is kind of a pet peeve of mine, why we wouldn't make it simple to just find everything that we're looking for. But it was decided for one reason or another that that's why it is done that way. So CAD downloads, I use this pretty much every week. And that's interesting because I have all these parts saved locally. So the fact that I have to continue to download new fittings, they're there at our disposal. So again, if you have any questions, please let me know, but it's pretty straightforward. The next one I wanted to touch on is going to be the CV calculator. The CV calculator, when you click on that, doesn't open a new window. So for this, we're going to do it as a new window just so I don't lose my tools page here. The CV calculator is designed for valve sizing. It's not designed for regulator sizing. We used to have a giant red note on here not to use it for regulators. It happened right around here. In lieu of that, we put calculator for valve sizing. It's not for regulator sizing. We're going to get into regulator sizing after this, or shortly after this. There's a nice bulletin link right here for how to select valves, some things to think about. It goes through orifice sizing, goes through valve design, just to kind of help you get some background in why or where you would select a valve depending on the application. There's an interesting math calculation here if you really wanted to know how to calculate the flow rate based on some geometry that's going to be difficult to pick out of the normal catalog. So to save you from having to do these calculations every time, we have this calculator here. It also should be noted that all of the gas pressures that are called out are going to be in absolute pressure unless you select PSIG. So if you normally work in bar, and I know most of us don't, if you do, be aware that it's bar absolute. It's not bar gauge. If you're not sure which valve, after you come up with a solution here, if you're not sure which valve it is, you can click on this link as well. And that's going to give you an option to go through any of our other valve offerings, whether it's a ball valve, a bellows valve, etc., to find out which valve is going to be appropriate based on the calculations that we do here. So there's a couple of different ways to use this. You can do a CV calculation or you can do a flow calculation. CV is going to be based on you having your flow requirement. Your flow calculation is going to be based on you having a flow coefficient detail. And you can do these for liquid or for gas. For this example, we'll do a CV calculation for gas. I'm going to assume that we have an inlet pressure of 250 PSIG. The outlet pressure is going to be 245. So we've got a 5 PSI pressure drop across this valve. It's going to be at 70 Fahrenheit. We're going to use nitrogen gas because most of you are using nitrogen in some way, shape, or form. The flow that I want to get through this valve is 100 SCFM. If I don't want to use cubic feet per minute, I can change into a couple of different options. And it's okay if your units aren't consistent. You can use PSI with metric flow rates. You can change your temperature from Fahrenheit to Celsius to Kelvin if you get into that. You're able to do that if you need to, because I know some of us don't always work in standard or consistent units. So whatever units you have, you can adjust that to run a calculation. It's based on these flow parameters, based on your inlet, outlet pressure, the flow rate that we want. In order to get this to work, we need a valve that has a flow coefficient value of at least 2.78. So when I think of what kind of a valve that likely is, my head goes to a ball valve. So if we're looking through our catalogs here, and I go to ball valves, this likely is going to be, and this is going to list all of our valve series top to bottom. So what I'm going to look for is our 40 or 40G. I can open up our catalog here. Every Swagelok valve catalog is going to list what the flow coefficient is of a valve. So for a ball valve, that's going to be when the valve is open. When you get to a needle valve or a bellows valve, it's going to assume the valve is wide open. It's not going to be kind of in between. There'll be some charts to show you how to read flow coefficients on multi-turn valves. So what I'm looking for in this catalog is going to be right here, flow coefficient in a straight pattern, and it's got to exceed, what did I say here? 2.78. So as we go down top to bottom, I'm going to blow this up so you can see it a little bit better. First one that I come to is going to be a 3/8 Swagelok ended ball valve. So there's two 3/8 Swagelok ball valves. One's the 44 S6, the other one's the 43 S6. If you were to say, hey, this is the one that I need, order me a 3/8 ball valve, and we find out that we accidentally ordered this one, what you can do is work backwards and say, well, I needed to have 100 SCFM. The CV that I have on this valve is 1.5. It's not 2.7. So what possible flow can I get through this valve? This is going to allow you to go backwards, or you can be proactive on it and find out and do a flow calculation. So same working parameters, same inlet, same outlet, same temperature, same gas. Instead, I'm going to do the flow coefficient of 1.5 instead of that 2.78 that we calculated. So I want to know what the flow is through this. I can hit this recalculate button. This is going to be the flow that I could expect through that valve, given that flow coefficient, given these set of parameters. So the 100 SCFM that I want, I'm really only able to get 54. The thing about flow coefficient, it's a linear relationship between flow and what this value is. So those numbers seem to make sense from what we were seeing at a 2.7, 2.6. You're a little over half, which is a little over half of the flow requirement that we wanted. At the same time, if you were looking at this and said, hey, what kind of flow can I get out of this? You know, that's 6 flow coefficient. You should see something that's going to be 4 times this value. That's consistent. So the maximum flow you can get through a valve, you're able to get at least that 100 SCFM out of it that you're looking for. So this was done with nitrogen. There's a lot of different preloaded gases in here, from air, ammonia, butane. When you select these, it's going to change the specific gravity. That's going to change what the flow coefficient requirement is, or the flow that you can get through the valve is. The specific gravity is critical in understanding how much flow you can get through the valves. So doing the same calculation with butane instead of nitrogen, my flow decreases. It's the same inlet, same outlet, but because this one is, it's a different media, I'm getting different flow values out of there. So it's important to know what the gas is so you don't accidentally size it for a gas that you're not using. If a gas that you want to use is not in here, you can adjust this to say whatever you want. Let's say you wanted it to be oxygen. You know, the specific gravity of oxygen is going to be 1.1. I can pretend that it's oxygen, rerun the calculation, and find out what my flow value would be through this valve with that gas. You've got to remember that it's not butane anymore. It's whatever you overwrote the specific gravity to be. Another important thing, if you are going to find a flow calculation, make sure that you're in the right phase. Make sure that you're looking for a gas, or that you're selecting a gas if you're looking for a gas calculation and not a liquid, because you're going to get different answers. So pay attention to your units, pay attention to your phase, but this is a good double check for which valve is going to be appropriate to use. So again, this is only going to be for valves, not for regulators. If you don't have a good way to find a valve through here, we're happy to help. You know, instruct you how to use the CV calculator. We can do it with you over the phone or through a Zoom call or something else. There's a lot of different valve options. So again, based on what your system parameters are, we can help you select a valve that's going to be appropriate. We're going to start with this. If it needs to get more in depth, certainly we're going to do that. Are there any questions on the CV calculator?
And feel free to unmute your line if you do have a question.
Yep. This all must be crystal clear. All right. The next tool I want to talk about is going to be our material selection guide. So this is a neat presentation. which is right here. This gives a quick overview of, what is corrosion, how does it happen. What I want to draw your attention to is going to be this guide. So it's 37 pages. It's a smart document, so you can click on numbers. It's going to jump to the page. There's not an easy way to go back, but this allows you to, as you go through, kind of click on links, and then that'll get more specific into the issues that you're seeing. So from a troubleshooting standpoint, everything is going to see some amount of corrosion, and it's kind of up to us to decide where that corrosion is coming from and then how to prevent it. So it's going to get into different styles of corrosion. The nice portion of this is going to be right here. So this is going to be a visual overview of types of corrosion you can see in the field. And this is your key here too. So what is the type of corrosion? What does it look like in the center of the circle? On the left side in this little red box are going to be the materials that are going to be most affected by this type of corrosion. On the right side, this green bracket here are materials that will resist that style of corrosion. So if we were to look at this one, general or uniform corrosion, this would be kind of like rust. Red is bad, green is good. If you're red-green colorblind, I apologize. Left is bad and right is good. But you can click on this, you can see what it is. The most type of corrosion is rust or red rust. So it goes through how it forms, and then some precautionary measures to take to get rid of that. Certainly the environmental media is going to play a part of that, as well as the system media. But when we look at other options, here's all of your other high-performing alloys or stainless steel that we could use instead of carbon steel to prevent this from happening. And by clicking on any of these, it's going to take you specifically to that product page, to that material page. And in there, it'll cover chemical composition. It'll go through raw material availability, how it resists some of the other issues that we see here. But it's good seeing this overview, because sometimes we don't know what to call it. A lot of us do, but sometimes we'll see a picture and say, what is this? I've got something that failed this way. Well, maybe it's hydrogen embrittlement. Maybe, this is how it happens. And then you can troubleshoot it in this case. I don't want you to use this as the end all be all, only way to troubleshoot a material failure, but this will at least get you in the frame of mind of thinking what materials are going to be more corrosion resistant or system resistant based on how it's being used in the system, the other working parameters, the environment that's around there, so that ultimately you get a successful system performance. So this isn't a limiting list. These are going to be 8 of your most common modes of failure, with descriptions of how they naturally occur in the world, and then some options for how to fix that, how to address it, or prevent it from happening. Again, as we get a little bit further down, we're going to get into more specifics about some of the unique alloys, your 6 moly, your super duplex, why they're better, why they're more resistant, some of the chemical constituents that make up the strength, the hardness, the resistivity features of these. So there's a lot of specialized alloys. We don't get into too many of these with too many of you, but be aware that we do offer fittings, we do offer valves, regulators in special alloy configurations, Monels, Hastelloys, Inconels, duplex, titanium. We can offer those when your system needs it. This also is going to go through some engineered combinations. Sometimes we can use stainless steel fittings on different tubing. Really, depending on the application, this is a specialized option, but we do have standalone literature of tested and proven engineered combinations using stainless fittings with other special grade alloy tubing. Again, that's going to be linked right off of that main page here. There's also a couple of notes in here regarding NACE, which I just blew past. There we go. There's a lot of details regarding NACE and your Norstock certifications or qualifications. This has been coming up more frequently, I would say, in the last couple of quarters. This is going to go through which material can be NACE compliant, which material is not, and then, you know, between the restrictions and configurations, how we can offer a product that meets these based on your system requirements, based on your documentation requirements. And certainly there's other certifications, there's other qualifications that have been asked of us as well. They're not covered in this presentation. NACE seems to be the most common that we've run into in the past. Any questions on this document here? There's a lot of detail. It's a neat format. I like the ability to look at something and say, I've got a view of something that looks just like this. This verifies then what my initial thought was, that it is stress corrosion cracking. So how do I get rid of that? You know, I've got this material. What can I go to limit what's already happened? You know, for trial number 2, in thinking the material was going to be resistant, find out it's not. What can I go to? What's the next option? Okay. And always, if you have questions on material selection, about compatibility, about appropriateness of one valve over the other, please let us know. We're here to help you. We're here to consult with you and make sure that you're getting something that's going to be appropriate, that's going to work. You know, we don't expect you to take the onus on completely yourself to make that decision, to make that determination of which material, which valve is best suited. We're at any point able to review what your application is and help you through it. Okay. The last tool that we'll talk about today is going to be the regulator flow curve generator. This generator is going to be used for only the RHPS series regulators, not the K series. So these are the larger process regulators instead of the green handled K series that most are familiar with. So when I click on that link, here's the detail. At the bottom of this is going to be a link to the catalog. I'm going to leave this open for reference because we're going to need to refer to it when we're actually sizing some of these. And I'll show you why in a little bit. But this is the regulator series that we're talking about. They're a little bit larger. This is going to be 1/4 through 4 inch. And you have options for spring loading, for dome loading. And when we get to that point in selecting these regulators, I'm more than available to help you pick one that's best suited for these. So the flow curve generator allows you to do a couple of things. You can create a flow curve for back pressure regulators or pressure reducing regulators, and then you're able to put together up to 4 flow curves for either the same system or different systems on a single curve. So if you had an application that you wanted to compare one style of loading against another, you can overlay them on top of the same performance curve. If you wanted to do different gases and view those on the same curve, you can do that as well. I'll show you what those look like. This is your opportunity to identify your notes, your units rather. So we're going to work in PSIG, we're going to work in SCFM. Our line velocity units are going to be fractional, our temperature units are going to be Fahrenheit. We can make them whatever you would like them to be, however you want to see them. But for this, we're going to go with PSI, SCFM, fractional, and Fahrenheit. For this system, I've got a 1 inch regulator. A 1 inch regulator, I know, is an RSH 8. From our catalog, we can go to these as well. From a spring loading standpoint, general purpose spring, let me blow this up a little bit. General purpose spring loaded, you've got a 4, 6, and 8. If you're not sure which one is which, here's your 4, 6, 8, and then the size that's associated with that. So 1 inch RSH 8. So we're going to start with a 1 inch regulator. The pressure control range has got a lot of different numbers here, and there's no visibility of what these are locally. And I've talked to Swagelok about putting in here what the control range is. They're working on it. So this is why we need to have this catalog open. We're going to go to the ordering information page, and we're going to pay attention to field 7, the pressure control range. So all of these, 1, 2, 3, 4, 5, 6, 7, 9, 11, these are all of our different control ranges, the outlet range of a regulator. So the one I'm going to look at is going to be number 3, because in this case, I want our outlet pressure to be 200 PSI. The gas type, we're going to stick with nitrogen because it's easy. Our inlet pressure, we're going to say, is 250 PSI. And our inlet temperature, after we have all these working parameters, we're going to hit calculate. It's going to do some thinking, and then it's going to put together a flow curve that's specific to the application that you just put in there. So it's going to try and set an outlet to 200 PSI, given an inlet of 250, and it's going to show you what happens as we increase the flow from a no flow condition to a choked flow condition. What you're going to notice on this, there's actually going to be 2 curves. The blue one is going to be what the regulator does. And we're going to have this horizontal line, not horizontal, diagonal line. So this line is going to be your line velocity. When we specify gas, it's going to default to a maximum line velocity. That line is going to represent where that velocity is. So at that point, you're at 100 feet per second. So really, we want to make sure that anything that we size is going to be to the left of that line. Not that the regulator won't perform to the right of that line. It means that at that point, you've exceeded what's deemed a safe flow velocity in the line. So to the right of this, what you can see is excessive vibration. You can hear some noise. Ultimately, you're creating a less safe system by trying to size something on the right of this maximum line velocity line. So we're going to try and focus then on the left. So this is a nice tool because you can create an appropriate flow curve based on your system. If we look at what Swagelok gives us, and we get a ton of data from Swagelok, we may not have a curve that's appropriate for the condition that we have. This one right now, this would be the curve that we would look at to reference that. So an inlet condition of 250 PSI, you're going to be somewhere between this line and this line. There's a lot of guesswork in between there. If you didn't want to extend yourself and say, I'm going to guess it's right in here, you can create a curve that's going to tell you exactly where you're going to end up. So if we wanted to create a second curve just to see how this works, let's say we want to compare 2 of them. Let's say what I found out, I think my inlet pressure is going to be 250 PSI. Really, it's not. Really, I'm going to have 1,000 PSI. Can this regulator still handle it? We can compare these 2 the same way. So I'm going to make this one an error. I'm going to select improperly the control range. But we're going to do everything else essentially the same. It's the same gas. It's the same regulator. Same line velocity, same set pressure. Your inlet pressure is different, and I change the control range. When I do this, it's going to throw an error, say, hey, regulator 2, set pressure is above with the product limit, so you've got to choose a different control range. So we can correct that, recalculate it. Now it's going to give me 4 curves. You're going to notice that this line velocity is going to be the same. You're going to have one curve over the other because it's the same gas, it's the same regulator. So these are going to overlap, and you're going to have 2 different lines. So between this key, the blue line is going to be regulator 1, the red line is regulator 2. you're going to see a much smoother outlet curve. There's going to be far less droop on this one compared to the blue curve. You've got more pressure to work with. That means the regulator can react a little bit cleaner to flatten this flow curve out a little bit. So you can compare those two. If you wanted to compare then, let's say we want a third one. So I want that same series, but I want to have it dome loaded instead. Because I've heard some guy talk about regulators before, and he said that a dome loaded regulator works a little bit better than a spring loaded regulator in flattening a flow curve. We're going to do the same inlet pressure as the first one. So 250 PSI inlet pressure, 200 PSI set pressure. Still going to be nitrogen. The maximum line velocity is going to be the same. The control range is going to change though. I think this one ends up going to a 5. So this is a different part of the catalog. So now we're into the dome loaded instead of the spring loaded. Again, we're here to help size all of this. So don't feel that you have to memorize where all of this information is in here. So this is going to be control number 5. This is going to have a pilot regulator with it. Oh. This one. So when I recalculate that, now you've got 3 different curves. So you have the RS8 spring loaded, 250 PSI inlet. You've got the RS8 with 1,000 PSI inlet. And then you've got a dome loaded, an RD8 with your 250 PSI inlet. So what you're going to see is this is much flatter than this one with your same working condition. It drops off towards the end, but depending where your flow ends up, you're showing in this situation how a dome loaded flattens your flow curve from a spring loaded, while looking at the possibility of having an increased inlet pressure upstream compared to a lower inlet pressure. So this gives you a lot of potential to troubleshoot and size and pick some different options for your regulator applications. One thing I have noticed with this is if you went back to try and change units, if you wanted to say, I don't want Fahrenheit, I need it to be Celsius, because the temperature I put in is actually 70 Celsius, not 70 Fahrenheit. On occasion, it'll throw an error and it'll only draw one curve, or something will be off with it. If you get to that point, just hit your reload button and start over and select it all brand new. It's pretty simple to re-enter all of this data. If you're going to start changing units, I recommend that you reload the page, start over, and create brand new curves off of that. Back pressure is going to work exactly the same. It's only going to give you a couple of different options. There's only a couple of different back pressure regulators that we have curves for, that we have data for. But you can do these. Downstream pressure usually is going to be 0 on a back pressure regulator. If you want it to go to nothing, to atmosphere, but if you do have a positive pressure, you can add that in there as well. And our back pressure curve is going to increase just like it should. So it's a nice tool trying to create a specific flow curve for an application to prevent you from having to interpolate some of the previously pre-generated curves that exist in our literature. Instead of going to this maximum rate all the time, usually there's going to be something in between that you're going to have to assume what the regulator is going to do. So this tool gives you a very quick and easy method of generating a flow curve so that you can see when you do increase your flow, what happens to the outlet pressure, how does that affect the performance, and ultimately, is it still safe to use in that application. Are there any questions on that? there any questions on anything that's been brought up with any of these tools? In the CAD file, download the CV calculator, your material selector, regulator flow curve generator. Again, they're all pretty simple to use. They do have, it's nice to be familiar with them. So if you get a chance, go in, play around with the calculators, play around with your flow curve generators, see what it is capable of doing, see what it's not capable of doing. All of these are in there. No? No questions? No? All right. That is the extent of the material that I have to cover. If at any point you have questions on